We're going to talk about two old television personalities in this lecture. One's a journalist we've already mentioned. The other's a comedian. We'll start with the journalist, Mike Wallace. You might remember I've talked about Mike, the tough guy correspondent who suffered from depression. I mentioned him way back in a previous lecture. Mike Wallace was an uneasy hero of mine. He was a game show host, a television star, and eventually a news reporter. You might recall him as the confrontational anchoring presence of the long-running news magazine show 60 Minutes. I use the word uneasy because he was so darn smart, but he could be an ass. For years, he'd fly around the world raising hell with bad guys, challenging world leaders, investigating all kinds of disturbing events. And he did it a long time. He didn't shuffle off his mortal coil until age 93. Even as an octogenarian, Mike Wallace was prosecutorially smart. Mike didn't retire from 60 Minutes until he was 88 years old. Even after he appeared on numerous interviews, he did his last 60 Minutes stint at age 90. I want my brain to age with the vigor of Mike Wallace. I bet you do too. The question we're going to tackle in this lecture is, what can we do to have the aging brain of Mike Wallace? The question I'm really going to tackle is how we can improve executive function, like I promised last lecture. As we'll see, we will address both questions by taking up the subject of physical exercise, which is the subject of this lecture. I'll divide our journey into Mike's brain into three parts. We'll talk about the first hints that linked exercise to improved cognition, though I really mean executive function, then move to effects on memory, and end with a discussion about mechanisms. The practical application section will discuss what type of workout gives the most benefit to the brain. And we'll begin with a study called a name that isn't in use much anymore. It's called ELSA. ELSA stands for the English Longitudinal Study of Aging. This notable, quotable, famous United Kingdom study has been following how a huge group of Brits, thousands strong, age in life. The study's been going on for years. The researchers are examining physical health outcomes, emotional health outcomes, diet, exercise, and so on for the entire cohort. Data has started to come in. As the study progressed, they noticed several interesting findings for which there is both good news and bad news. First, the good news. There were whole groups of people who were aging just like Mike Wallace. They were bright, energetic, had low levels of memory loss, didn't become sick nearly as often as others in the group. They were transiting through the aging process with grace and aplomb. They were aging just like you and I probably want to age. Now the bad news. There was another group in this cohort that weren't aging very well at all. They displayed more of the stereotypical aging disability behaviors, lower levels of energy, higher incidence of major chronic disease, more physical problems in general, and more mental problems as well, including disturbing memory loss. There weren't very many Mike Wallaces in this room. Turns out it was a continuum of behavior with lots of intermediate aging outcomes in the middle. The question you can ask about this polarity is, what's up with the two groups at the poles and the continuum? Is there an independent variable that can predict which age group you're going to fall in? Is there a behavior, say, that when present greatly predicts your ability to transit through the aging process beautifully? The answer's yes, and it's a bombshell. The presence or absence of a sedentary lifestyle predicts how well you are going to age. If you are active, you will statistically age like Mike Wallace. If you are not active, you won't transit through the aging process very well at all. You'll grow old like the second group grows old. You won't find the experience very comfortable or very long. You'll age like a character played by the second television celebrity I mentioned, the comedian. He was a famous member of an old television variety program called The Carol Burnett Show. His name was Tim Conway. Tim Conway had a recurring character, usually called some variant of Oldest Man. There were many incarnations of Oldest Man, from the oldest butcher to the oldest wardrobe manager. Now, each helping of physical sketch comedy was different, yet Oldest Man displayed recurring behaviors associated with aging. He shuffles, he gets confused, he doesn't know where he is, he can't hear anything. The funny thing about Tim is that he is now nearly the same age of his old man characters. Says he, quote, "My career is pretty much over. I'm out in the valley eating soft-boiled eggs," close quote. These days, we might be tempted to call this stereotype ageist. Yet I admit, he's funny to watch. And it's painful too, because his character is a spot-on example of the people in that British study who are not aging like Mike Wallace at all. The first question we want to answer is, what exercise produces what benefit? The second question we want to answer is, why? Let's do the what first. We have a lot from which to choose. Now, as you know, there's lots of peer-reviewed connective tissue linking physical exercise to bodily health. The earliest returns showed that exercise returned powerful benefits to your cardiovascular system. But scientists couldn't help but notice that people like Mike Wallace didn't only have better hearts, they had better minds. So the hypothesis was floated that perhaps physical exercise had physical effects on the brain just like it had on the heart. They might be related, of course. After all, the brain has its very own blood system, which we call, logically enough, the cerebrovascular system. But still, it was an important question, and it has a whopper of an answer. A great deal of research went into the question. It appears that Mike Wallace is smarter than Tim Conway's Oldest Man. Was he? After a great deal of work, the answer came back in a resounding way. The answer was yes. We have proof of this from what's called a meta-analysis. Put simply, a meta-analysis is a collated examination of the findings of many research papers, an analysis of an analysis, all to see if a trend can be noticed. In the case of exercise and smarts, such meta-analyses have been done. One of the most famous comes from researcher Art Kramer. He took a total of 18 intervention studies and asked, did exercise interventions improve cognitive performance? The answer was yes, and in virtually every way you can measure cognitive performance. Visual spatial abilities improved, reaction speeds improved. The strongest effect was seen on executive function skills. Remember those skills from last lecture? That's the stuff involving cognitive control and emotional regulation. Here's a quote from Art Kramer's paper. Fitness training was found to have robust but selective benefits for cognition, with the largest fitness-induced benefits occurring for executive control processes. That meta-analysis was done years ago. But here's the cool thing. The story has only gotten more robust as the years have passed. The linkage between aerobic exercise and executive function has proven to be particularly powerful. But aerobics is not the only type of exercise that shows benefit, and executive function is not the only type of cognitive benefit affected by exercise. It's one of the most optimistic things I can tell you to say that there are things you can do to slow down the brain's otherwise natural age-related decline. In some cases, you can even reverse the erosion. This optimism reminds me of an incident involving a man known for positive, sunny dispositions well into old age. He eventually died of Alzheimer's disease, but in his lifetime also became the 40th President of the United States. The incident occurred during a debate in his re-election bid. I am, of course, talking about Ronald Reagan. Ronald Reagan was 73 when he ran against Walter Mondale in the election of 1984. That was considered old back then, and Reagan's cognitive function became an issue in the campaign. Journalist Henry DeWitt asked Reagan if his age would be a factor in his decision-making ability. Reagan's reply was legendary. Quote, "I want you to know that also I will not make age an issue of this campaign. I am not going to exploit, for political purposes, my opponent's youth and inexperience." It brought the house down. It even elicited a belly laugh from his opponent. President Reagan got many factual matters wrong in that debate, to be blunt. But at that moment, he seemed alive and vital and apparently convinced lots of voters he was up for the job because it worked. He won the election in a landslide. As I mentioned, Ronald Reagan eventually died of Alzheimer's disease. But given his hearty disposition, the question researchers are asking is, did he have to? As with most human behaviors, there are both nature and nurture questions to consider in addressing this question. Here's the reason. We now know memory can be improved with physical exercise. As we'll see, it can actually reduce your risk for getting Alzheimer's. It's also good for vascular dementia and even clinical depression. Let's get started on this optimistic path. To do it, we need to review some notions we haven't visited since our discussion about crystallized intelligence way back in lecture number 6. Let's talk about exercise and memory. Human memory seems to work like a single, well-tuned hard drive, but it doesn't. You might remember this from that crystallized lecture. Human memory is actually not like a single, well-tuned hard drive. There appear to be many memory gadgets in the brain. They each cover different, though often overlapping, learning domains. And they tend to work in a semi-independent fashion. Figuring out how to ride a bicycle is neurologically distinct from learning your multiplication tables, for example, and both are different from remembering fondly a picnic with your kids. In Alzheimer's disease, you can forget your name, but you seldom forget how to walk. We're only in the beginning stages of learning how this non-unitary collection of cognitive gadgets works together. But there is one thing that's clear. There are now lots of data showing exercise can improve the function of memory. Not all types of exercise, and not all types of memory, but it's clear that where there's exercise, there's improvement. Here's one example. Aerobic exercise can improve episodic memory in senior citizens. Episodic memory is the type of memory that allows you to recall an incident that happened to you or to someone else and comes complete with casts of characters and a timeline. It's like an episode from a favorite TV show you remember having watched, which also possessed characters that moved through time. In one experiment, episodic memory skills of test enrollees were measured as a baseline. They then underwent a 6-month aerobic fitness program. The improvement in episodic memory was dramatic. The effect was even found to be dose-dependent. The more aerobic activity you did, the bigger the boost became. Episodic memory is not the only memory gadget positively affected by aerobics. Getting on a treadmill can improve spatial memory too. Exercise can also improve another type of memory measured by something called a paired associates test, using a type of memory that allows you to memorize facts. One result showed a boost in healthy adult males after only 30 minutes on a treadmill. Admittedly, most of this research examined elderly populations. What about younger populations? There is increasing evidence that exercise can improve the memories of pediatric populations too. One study of 7 to 9-year-olds showed an increase in the proficiency of working memory, that temporary desktop workspace of Alan Badley, in an after-school physical activity program. It is an extraordinary thing to say, but fit children quite literally memorize things better than unfit kids. So you can see the effects of exercise across the lifespan. As I said, most of the work has been done in aging populations. And if you read through this literature on the web, you begin encountering many marvelous stories about old people whose brains seem as young and as lively as the pediatric populations I just mentioned. I'm going to read to you a story similar to the one I related back in lecture number 6 that fit into this collection nicely. I have heard public speakers use this anecdote when they describe how many senior citizens retain their bright, lively minds well into old age. Quote, "A reporter was interviewing a 104-year-old woman and asked, 'What do you think is the best thing about being 104?' She simply replied, 'No peer pressure.'" Anecdote or not, I'd love to be that lively at 104. Heck, I hope I'm that lively at 74. As this optimistic story continues to unfold, the benefits keep mounting. Take that great worry most older people have about their aging minds, the risk of dementia. Two of the biggest worries are the various vascular dementias and, of course, Alzheimer's disease. Exercise can alter your risk for these pathologies, and the data come right out of the vascular benefits corner of the exercise research world. Let me explain. Some of the most serious risk factors for these dementias are vascular in nature and include hypercholesterolemia, blood pressure issues, by that I mean hypertension, and the famous fat-induced type 2 diabetes. The risk for acquiring these vascular pathologies are greatly reduced if you exercise regularly. What is the link of exercise with changes in vascular dementia? The factors are complex and not well understood, though the basic issue is fairly simple to understand. Vascular dementias occur because of problems supplying blood to the brain. We know that exercise can induce positive changes in that blood supply, actually increasing the density of the cerebrovascular bed, number of blood vessels circulating through specific regions of the brain, at least if you are a laboratory rodent or a pig. Findings in humans have shown that exercise increases blood volume to specific areas of the brain involved in learning, mediating something called neurogenesis. I'll have more to say about neurogenesis in just a few moments. Is it possible that exercise buffers against dementia by increasing the number of routes blood can take into the brain? At this point, we just don't know. How these relate to dementia is under active investigation. Perhaps not too surprisingly, the cognitive pathologies are reduced too. What people didn't predict was how greatly they can be reduced. Active people literally cut their risk for general dementia in half. These same fit people enjoy a 60% reduction in the odds of getting Alzheimer's disease. It works for even mild cognitive impairment. One research paper estimates that if the world reduced its couch potato behaviors by a paltry 25%, 1 million cases of dementia could be prevented. Even mild cognitive impairment is reduced. And dementia is not the only psychopathology physical exercise addresses. There is now abundant evidence that regular exercise buffers against the risk for certain affective disorders, particularly clinical depression. It can also be used as a companion therapy for people who are already in the grips of a depression. One of the reasons why it works is because fit people tend to handle the stressors of life better than non-fit people. Seems to build in a form of resilience. It's so effective, it even helps alleviate depression in people who are suffering from chronic illnesses. A meta-analysis review, remember that's an analysis, of over 90 studies was done on the subject. It showed that exercise was very effective in alleviating depression in people with a wide variety of illnesses, from cardiometabolic disorders, heart disease and certain metabolic disorders like diabetes, cardiovascular disorders, to cancer and fibromyalgia. Depression and exercise presents an interesting case. It's one of those few practical activities you can do that break people out of what I call a cycling behavior. One of the hallmarks of depression is decreased physical activity. The more depressed you feel, the less likely you are to move around. The less you move around, the more depressed you feel. Forcing yourself to get regular exercise has the ability to break this habit. As we'll see in a minute, exercise can actually activate the brain's own antidepressants. Now, I should warn you, exercise is not a replacement for actual therapy and antidepressant medications. If you are currently taking them, you are not allowed to quit taking them until you've talked to your doctor. Don't throw me a lawsuit. But, by all means, tell your doctor about the effects of exercise. Show your therapist this course. The best of all worlds suggests that exercise, in combination with medication and psychotherapy, is a powerful new therapeutic ally in keeping depression at bay. There is a picture of a man who seems to fit all this in nicely. One of the oldest persons ever to successfully complete a marathon, 100-year-old Fauja Singh finished the Toronto Waterfront Marathon in 2011. His time? 8 hours and 11 minutes. Not to be outdone, he completed a 10K marathon in Hong Kong 2 years later. Yes, that means he did a 10K race at the tender age of 102. Here's the weird thing. He started running at age 89 after a family tragedy where he lost both his wife and his son. Another person who fits this bill nicely is Ida Keeling. In 2012, she ran a 100-meter sprint in 51.85 seconds. She did it at age 97, which beat the previous record in her age group. A lot like Singh, she took up exercise after some setbacks in her personal life. Her husbands and her 2 sons had died, so she started her exercise journey at age 67. How come these people age so well, even with all that adversity? What does exercise do to the brain? You probably already know what I'm going to say. There are both nature and nurture sides to this story. There are both social and genetic answers to these questions. Scientists knew where to start looking. Since the hippocampus is so deeply involved in human learning, their investigation into exercise began by targeting these tissues. That strategy has struck research gold. There are many cellular and molecular things that exercise does to the hippocampus, and even beyond. There are 3 findings regarding exercise and the hippocampus. This first set of findings can be explained simply by telling you the title of the paper that described it. Here's the title: Exercise Training Increases Size of Hippocampus and Improves Memory. Here's the story. Hippocampal volume naturally decreases as we get older. Yet researchers knew for a long time that fit people tended not to suffer as much decline. In this experiment, researchers took measurements of the hippocampus of 120 older adults, exercised them, then took measures again after. At the same time, they monitored memory ability both before and after. Here's how the researchers couched their findings. Quote, aerobic exercise training is effective at reversing hippocampal volume loss in late adulthood, which is accompanied by improved memory function. Finding number 2, increased neurogenesis. This next finding won't make any sense unless we know what neurogenesis is. Several regions in the brain are capable of giving birth to new neurons, undergoing neurogenesis, all your life long. Neurogenesis is the process where pre-neurons, called neural stem cells, give rise to adult neurons. A particular part of the hippocampal formation, that region known as the dentate gyrus, is one of those regions. It's nice to have a ready supply of new neurons in regions of the brain involved in learning, particularly in the hippocampal formation. And that's exactly what aerobic exercise does. Aerobic exercise increases neurogenesis in both lab animals and humans. If you want to have more brain cells involved in learning, and many researchers argue that's a good thing, you need to exercise. Finding number 3, increased BDNF. These data may explain the second group of findings, that neurogenesis, that is, those new neuron stuff, but to understand it, I have to explain what BDNF means. BDNF stands for the tongue-twisting, brain-derived neurotrophic factor. BDNF is a protein that does lots of things all over the body. It does particular things in the brain. In fact, you can call it a vitamin for the brain. BDNF is involved in stabilizing newly formed synaptic interactions. It's involved in memory formation. It protects against stroke. And it's involved in neurogenesis, that neural birth stuff. Here's the finding. Exercise increases circulating levels of BDNF and in the brain. Exercise increases BDNF production at the level of the gene in the hippocampus. That's thought to be a good thing by virtually everybody who knows about these data. It may help to explain why exercise is so good for learning. And if that's the case, we have the rarest thing in all the cognitive neurosciences, an alignment between researchers working on behaviors, researchers working on cells, and researchers working on genes. There have been lots of investigations since then. Some of it has been practical in nature. My guess is you've been asking yourself questions like, okay, what type of exercise is best? And if you're like me, how much of it do you have to do? It is to these issues that we turn next in our practical application section. I have to admit, I do not come easily to this issue. I lead a very sedentary life, even though I was active in my younger years. My career has led me to a very sedentary lifestyle. But I ended up setting a treadmill up in my office and started exercising when I answered emails and wrote things for one simple reason. These data are not opinions. You can see a video of my apparatus on the website brainrules.net. So I get it that some of this is going to be hard to hear if you sit on your butt for a living. In fact, there is a Q&A I found that suits the attitude I bring to this to a T. I call it Ode to a Sedentary Carnivore, paraphrased from a Q&A session at the University of Ottawa. I've heard that cardiovascular exercise can prolong life. Is this true? Answer, no. Your heart is only good for so many beats, and that's it. Don't waste them on exercise. Everything wears out eventually. Speeding up your heart will not make you live longer. That's like saying you could extend the life of your car by driving it faster. Want to live longer? Take a nap. Question, how can I calculate my body-fat ratio? Well, if you have a body and you have fat, your ratio is 1:1. If you have two bodies, your ratio is 2:1. Question, should I cut down on meat and eat more fruits and vegetables? Answer, you must grasp logistical efficiencies. What does a cow eat? Hay, corn, what are some of these? Vegetables. A steak is nothing more than an efficient mechanism of delivering vegetables to your system. That's the lens through which I view these data. Of course, none of this is true. In fact, all of the practical things I have told you about in this course, the type and amount of exercise you need to get the cognitive benefits, are easily the most well-researched. Let's talk about the mechanics. How much do you need to do, and of what type? The answer is extraordinary because the answer is not much and aerobics. The most well-researched benefit appears to be aerobic exercise. There are also important effects that can be had with strengthening exercises. We'll stick to the aerobics in the interest of time. Here's how much aerobic exercise that's generally suggested. You can call it the gold standard. To get most of the benefits I've been talking about in this lecture, you need a moderate aerobic workout, 150 minutes a week. By moderate aerobic activity, I mean walking too fast to sing. The 150 minutes in a 7-day period for most of us would be your standard Kenneth Cooper workout, 5 days a week. Ken Cooper is a retired Air Force physician who wrote the 1968 bestseller Aerobics. He is mostly responsible for advancing the concept, then figuring out the optimal parameters for a healthy cardio workout. It's not much if you think about it. In fact, researchers have tested the threshold, perhaps tailored for guys like me who don't ask, how much do you need to do, but more like, how little can you get away with? What they found is that you need to do an astonishingly little bit to start reaping big benefits. You might recall that ELSA study we started with, the one measuring Brits who were aging? Researchers supervising this study showed that if all you do is 1 hour per week of moderate to active exercise, you could see benefits over people who didn't do any. Moderate here means, to quote lead author Mark Hamer, gardening, cleaning the car, walking at a moderate pace, or dancing. That's nuts. It's also true. There's even more good news. You can start at any age and still get amazing benefits. Researchers examining that British cohort studied couch potatoes who sat around most of their lives and then suddenly started a regular active exercise program in middle age. These guys enjoyed a 7-fold reduction. Yep, I just said 7-fold reduction in their lifetime risk of getting sick with the maladies that generally afflict people in their old age. So it's never too late, and it's never too little. Here's a question you can ask. What's up with all that? How come it takes so little? And the answer I will give you is, of course, Darwinian in nature. In our species' sojourn through our hunter-gatherer phase, we were in constant motion. If we sat still in the brutal world of the Serengeti, we could be lunch. We were constantly moving, running up and down hills, fording streams, climbing over rocks, most of our waking hours 7 days a week. Some researchers believe we moved an average of 10 to 20 kilometers per day, and that was normal. Here's the implication. Our big, fancy Pleistocene brains grew up under conditions of near constant motion. It performs best when we repeat the conditions under which it was tuned to perform optimally. If you just nod your head towards motion, an hour a week of gardening, for heaven's sakes, the brain just laps it up. You are repeating its evolutionary history. We think exercising doesn't make your brain function optimally. We think exercising simply makes your brain function normally. You could have asked Mike Wallace or Tim Conway. They both could have told you the same thing.